Welcome back, I'm Dr. Dan, and today we're exposing a hidden force shaping our world: rare earth minerals. These minerals are the backbone of modern technology, from electric vehicles to smartphones and advanced military systems. But what happens when one nation controls the supply? China's strategic grip on rare earths is a silent weapon, capable of halting industries and shifting global power. This isn't just about geology. It's about who holds the keys to our technological future. The story of rare earths is a lesson in how economic dominance becomes geopolitical leverage. Understanding this dynamic is crucial for anyone interested in the future of technology and global strategy. Let's unravel how China turned a niche resource into a cornerstone of international power. Picture April 2025. No war, no pandemic, just a single government restriction, and the world's economy shudders. China limits exports of 17 rare earth minerals. Suddenly, factories in the West grind to a halt. Electric vehicle production stops. Defense contractors panic. Tech giants scramble for supplies. These minerals, once obscure, are now headline news and the subject of emergency meetings worldwide. Their absence exposes a critical vulnerability. The world's most advanced industries depend on resources controlled by one nation. The message is clear. The rules of global power have changed. Control of raw materials is now a primary instrument of national strength. Every major economy is forced to rethink its security and future. What are rare earth elements? 17 metals including the lanthanides, scandium and yttrium. They're essential for electric vehicles, wind turbines, smartphones and more. Neodymium and praseodymium create the world's strongest magnets, crucial for EV motors and wind turbines. Rare earths power data centers, fiber optic cables and advanced military tech. Their unique properties make them nearly impossible to replace. Without them, modern technology would stall. They're not just important, they're foundational. Whoever controls rare earths controls the pace of innovation. These elements are the ultimate choke point for progress. That's why their supply is a matter of global power. Despite the name, rare earths aren't geologically rare. Elements like cerium are more common than copper. The real challenge is concentration. They're scattered, not clustered. Extracting and separating them is complex and hazardous, often involving radioactive elements. The bottleneck isn't scarcity but the difficulty of turning ore into usable metals. Only a few countries have the expertise and infrastructure to do this at scale. China mastered the entire process, from mine to magnet. That's how it achieved dominance. Not by having the most, but by refining the best. Refining rare earths is messy, toxic, and energy-intensive. Mining creates huge amounts of waste, often laced with radioactive materials. Separating the elements requires hundreds of chemical steps and generates tons of hazardous byproducts. Environmental regulations pushed Western countries out of the business decades ago. China stepped in, accepting the pollution for market control. The world got cheap, rare earths at the cost of losing control. Outsourcing the dirty work meant outsourcing power. That trade-off handed China the keys to the high-tech kingdom. China's dominance wasn't luck, it was strategy. In the 1980s, leaders saw rare earths as the new oil. The government invested in mining, refining, and research, building the entire supply chain. State support and subsidies, lax regulations gave Chinese producers a huge edge. China sold rare earths cheaply, undercutting global competitors and driving them out. The goal: total market control, no matter the cost. The result: the world's tech industries now depend on China's supply. This is how a niche resource became a global power lever. As China executed its long-term plan for rare earth dominance, Western nations faced mounting economic pressures and growing environmental protests at home. Stricter regulations and public outcry led to the closure of domestic mines and refineries. The Mountain Pass mine in California, once a global leader, was abandoned. Meanwhile, China offered a steady supply of rare earths, absorbing the environmental costs others shunned. Western companies offshored the problem, importing cheap materials and exporting pollution. In doing so, they lost not just the mess, but also their expertise and strategic independence. China eagerly filled the void, becoming the world's refinery and accepting the risks. This trade-off created a deep strategic vulnerability for the West. China gained near total control over resources critical to the modern economy. China's strategy created a completely integrated, state-controlled ecosystem. From resource extraction to finished products, China wanted to sell the world's sophisticated components. By the early 2000s, China led in both mining and manufacturing. They mastered metallurgy and perfected magnet production for electric vehicles and wind turbines, creating an unbeatable advantage. By 2025, China processed over 85% of rare earth oxides and produced nearly 90% of high-powered magnets. This dominance gives China geopolitical leverage, influencing prices and restricting supply. The world found its advanced industries built on ground controlled by a single, powerful nation. In April 2025, everything changed. The simmering geopolitical tensions between China and the United States finally boiled over, but not in the way many had predicted. There were no naval blockades or new rounds of sweeping tariffs. Instead, Beijing chose a far more surgical and sophisticated weapon from its arsenal. It tightened its grip on the global supply of rare earth elements. With a series of carefully crafted announcements, China's Ministry of Commerce declared new export licensing requirements for critical rare earth materials and high-performance magnets. The move was a masterclass in strategic coercion, a quiet but devastating show of force. The new regulations were not a blanket ban, which would have been too crude and provoked a unified global backlash. Instead, they were cleverly designed for maximum impact with plausible deniability. The rules stipulated that exports of specific materials, particularly heavy rare earths like dysprosium and terbium, and the neodymium iron boron magnets they are used in, would now require special government approval. The official reason given was to protect national security and conserve strategic resources. However, the unspoken message was crystal clear. The policy was aimed squarely at nations that had imposed their own export controls on advanced semiconductors and AI chips destined for China. This was not the first time China had hinted at using this leverage. In previous trade disputes, the idea had been floated in state-controlled media as a veiled threat, but this was different. This was no longer a theoretical risk, it was a live, active policy. The Chinese government was now actively demonstrating its willingness to use this power. The era of assuming an uninterrupted flow of these critical materials was officially over. The world was about to receive a crash course in the geology of power and the fragility of its own supply chains. The timing was impeccable, designed to inflict maximum psychological and economic pressure. It came just as Western automakers were ramping up electric vehicle production and governments were pouring billions into green energy infrastructure. By targeting the very components essential for these initiatives, China was striking at the heart of the West's economic and environmental ambitions. The export shock of April 2025 was a calculated move, a geopolitical signal sent not with warships, but with control over the periodic table. It was a clear declaration that the new great power competition would be fought on factory floors and in the mines that supply them. The impact of China's export restrictions was immediate and brutal. Within weeks, the carefully calibrated just-in-time supply chains that underpin modern manufacturing began to seize up. In the United States, Ford was one of the first major casualties. The company announced a temporary shutdown of its Chicago assembly plant, which was responsible for producing several of its popular EV models. The official statement cited a critical shortage of high-performance magnets for their electric motors. The production line, a symbol of America's pivot to a green automotive future, fell silent. Thousands of workers were furloughed, and the company's stock price took a significant hit, sending a chill through the entire industry. The shockwaves quickly spread across the Atlantic to Europe's industrial heartland. In Germany, BMW, a giant of the automotive world, was forced to announce delays in the shipment of its flagship electric vehicles. The company's executives admitted that their supply of essential motor components, sourced almost exclusively from Chinese magnet producers, had been severely disrupted. The situation was the same for Volkswagen and other European car makers who had bet their futures on a rapid transition to electrification. Suddenly, their multi-billion-euro investments were held hostage by a supply chain bottleneck that originated thousands of miles away, revealing a critical vulnerability at the core of Europe's industrial strategy. The technology sector was not spared. While consumer electronics have shorter production cycles, the threat was just as existential. Tech firms like Apple, which rely on tiny, rare earth magnets for speakers, cameras, and the haptic engines in their iPhones, began quietly stockpiling any parts they could find. The fear was that the magnet shortage would soon translate into production halts, or, at the very least, significant price increases for their flagship products. The entire ecosystem of consumer gadgets, from laptops to smartwatches, was suddenly at risk. The invisible components that made these devices work were now dangerously and visibly scarce. Perhaps most alarmingly, the defense industry sounded a public warning. The Pentagon issued a memo highlighting potential bottlenecks in the manufacturing of advanced weapons systems. Precision-guided missiles, F-35 fighter jets, and advanced drone technologies all depend on the unique properties of rare earth elements for their guidance and control systems. Defense contractors, who had long operated with the assumption of stable supply, were now forced to conduct urgent audits of their supply chains. The export shock was no longer just an economic inconvenience, it had escalated into a pressing matter of national security for the United States and its allies. The initial factory shutdowns were only the most visible symptom of a much deeper crisis. The export restrictions set off a frantic chain reaction that rippled through global markets, affecting far more than just the end product manufacturers. The price of the few rare earths and magnets available outside of China skyrocketed almost overnight. Traders and speculators jumped into the market, driving prices for elements like neodymium and dysprosium to record highs. This created a new layer of chaos for businesses, as the cost of securing the raw materials for everything from industrial motors to medical MRI machines became wildly unpredictable, making long-term planning an impossible task. This price volatility spread to adjacent industries. The renewable energy sector, a key pillar of global climate goals, was hit particularly hard. The giant wind turbines that are essential for large-scale clean power generation rely on massive permanent magnets, some weighing several tons. With the cost and availability of these magnets now uncertain, planned wind farm projects around the world were suddenly put on hold. Investment in green energy became riskier, threatening to derail the progress made towards reducing carbon emissions. China's move demonstrated that the path to a green future was paved with materials that it largely controlled. The crisis also exposed the lack of visibility within complex global supply chains. Many companies that believed they had diversified their sourcing discovered that their non-Chinese suppliers were, in fact, still dependent on raw materials or intermediate components processed in China. A German company might buy magnets from a supplier in Vietnam, only to find that the Vietnamese factory was importing its rare earth oxides directly from China. The web of dependency was far more tangled than most corporate procurement officers had ever realized. The shock forced a painful and costly remapping of these intricate networks, as companies scrambled to find truly independent sources. This widespread disruption created a climate of corporate panic. The dominant business philosophy of the past 30 years, lean manufacturing and just-in-time inventory, was proven to be dangerously fragile. The new imperative became resilience. Companies began a desperate search for alternative suppliers and started building up strategic stockpiles of critical components, a practice that had been dismissed as inefficient and costly for decades. The rare earth shock did not just halt production lines, it forced a fundamental rethinking of the very principles that had governed global manufacturing and trade since the end of the Cold War. The era of pure efficiency was over. The age of supply chain security had begun. The 2025 export shock was more than a trade dispute. It was a demonstration of statecraft. Beijing wasn't trying to cripple Western industry, but send a message. In an era of tech competition, control over foundational materials is power. China was reminding the world its dominance was an active tool. The action responded to Western efforts to contain China's tech. The rare earth restriction was retaliation. If you control microchips, we control the materials that power that tech. It was a geo-industrial chess move. This event exposed the West's strategic complacency. The shock laid bare the vulnerability of dependency on a rival nation. China's move signaled to the world that supply chains are contested. The export shock redrew the map of global power. The shock of April 2025 sent an immediate jolt through global industries, leading to a frantic worldwide scramble to respond. The urgent priority was to secure alternative sources of supply, breaking reliance on China. Teams of geologists and supply chain experts searched the globe for non-Chinese sources of rare earth materials. Nations like Australia, Canada, and Brazil found themselves at the center of a geopolitical bidding war. Strategic stockpiling roared back into fashion. Governments began to expand their national stockpiles of critical minerals. Companies embarked on deep-dive audits, tracing their components back to their ultimate source. This led to a shift in procurement strategy, prioritizing transparency and geographic diversity. The new mantra became China Plus One, fundamentally reshaping the map of global manufacturing. The global scramble included looking inward. The crisis sparked a movement to resurrect dormant mining and refining industries within Western nations. A prominent example was the Mountain Pass mine in California. MP Materials began an aggressive ramp-up of mining and rebuilding refining capabilities on site. Across Canada, Australia, and parts of Europe, new explorations were launched with unprecedented urgency. Governments, recognizing the national security implications, began to streamline permitting processes. A major focus was on developing new, cleaner processing technologies. The aim was to bring the industry home sustainably and responsibly. Experts cautioned that this renaissance would take years to materialize. Efforts could not replace China's vast capacity overnight. The global economy would remain vulnerable for the foreseeable future. The path to independence was going to be a long and arduous one. Alongside efforts to produce more rare earths, innovation began to gain momentum. Engineers innovated to design them out of products. If you cannot guarantee supply, the solution is to no longer need it. In the automotive sector, research surged into alternative electric motor designs like induction motors. Another major area of innovation was recycling. Millions of tons of electronic waste became urban mines. Governments and companies invested in recycling technologies, creating a circular economy. The global response was a testament to the power of innovation. It triggered a global scramble and a creative push for a less dependent future. The world learned a harsh lesson in strategic dependency. The April 2025 export restriction was a profound geo-industrial signal. China made it clear that global influence would be fought with control over raw materials. Control over critical minerals equals control over the technological future. Most advanced economies were dangerously unprepared. The global response revealed a deep dependency on China. Europe and Japan relied on Chinese processing for rare earth needs. Their industries were built upon a foundation they did not control. The United States was only beginning to rebuild its domestic refining capacity. The crisis highlighted a gap between America's ambition to lead in AI and green energy, and its lack of control over required materials. Beijing was quietly expanding its grip on the global mineral supply chain, securing assets across Africa and Southeast Asia. The rare earth crisis forced the creation of new strategic alliances based on shared mineral dependency. The United States and its allies recognized that no single nation could build an independent supply chain alone. This led to new partnerships, mineral security blocs, with nations like Australia and Canada. Recognizing the need for a broader coalition, Western nations began intensive diplomatic outreach to countries with mineral potential like Brazil and Vietnam. Groups like the Quad added critical minerals to their security agenda, launching efforts to map supply chains and establish sourcing standards. This was an attempt to build a coalition of democracies as an alternative to China's state-led model. This created a new arena of geopolitical competition, played out in the minds and boardrooms of resource-rich countries. The race was on to build a more resilient network, a contest that would define the economic landscape. The shock of 2025 ignited major policy changes within the United States and its allies, marking a break from the past. The U.S. Department of Defense elevated rare earths to the highest level of materials critical to national security. This unlocked new powers and funding, shifting it from an economic issue to a defense imperative. Congress authorized billions in new funding through acts like the CHIPS and Science Act and a revitalized Defense Production Act. This targeted rebuilding a domestic supply chain for critical minerals and developing advanced recycling technologies. This represented a return to a hands-on industrial policy, recognizing the market alone couldn't provide for strategic needs. Governments began funding R&D aimed at reducing dependency through innovation. Public-private partnerships accelerated the development of next-generation electric motors that use no rare earths. Ultimately, the crisis forced a re-evaluation of national security. Industrial capacity, technological leadership, and resilient supply chains were crucial. We are in the early innings of a generational effort to reclaim strategic independence. The policies being put in place today are the first steps towards a more secure future. This story is about the world you live in, whether the next generation of electric vehicles gets built, and the price of the smartphone in your hand. The events of April 2025 revealed a fragile dependency. The future of global innovation hangs in the balance. There is a path forward paved with bold innovation. It is built on strong international partnerships and smart, forward-thinking policy. It is a live, ongoing narrative that will shape the world for your children and grandchildren. If this video has helped you understand the hidden forces that are shaping the future of technology, manufacturing, and global strategy, then please help us share this knowledge. The first and easiest way you can help is to tap that like button below. It's a small click for you, but it tells the algorithm that this is a valuable conversation, helping more people to see this breakdown and become informed. It is a simple action that genuinely helps our channel grow and allows us to continue making in-depth content like this for you. Your support makes all the difference in getting these important stories out to a wider audience. Next, if you want more deep dives into the economics of development, the intricacies of global supply chains, and the realities of modern industrial strategy, make sure you subscribe to the channel and ring that notification bell. We're constantly exploring the critical topics that define our modern world, and by subscribing, you will not miss our future investigations. We believe that understanding these complex systems is the first step toward building a better, more resilient future. Your subscription is your ticket to staying ahead of the curve and being part of a community that is passionate about these crucial issues. We also want to hear from you. The conversation does not end when the video stops. Leave a comment below and let us know your thoughts. Do you think your country is doing enough to reduce its dependency on rare earths? What solutions or strategies would you push for? Do you think the focus should be on new mining, recycling, or innovation? Your insights and opinions are valuable, and the comment section is a fantastic place for this community to debate and share ideas. This is a complex problem, and the best solutions often come from open and engaged discussion. And most importantly, if you know someone who drives an electric vehicle, works in the technology sector, or is simply interested in understanding the true levers of global power, please share this video with them. Send it to a friend, a family member, or a colleague. The more people who understand this story, the more pressure there will be on our leaders and industries to make the smart, long-term decisions that are needed. Because this story is far from over. In fact, it is just getting started, and you deserve to be part of the conversation that shapes what happens next. Thank you for watching.